Thank you.
Hi everyone.
Hi. Uh, Thanks everyone to join the call. What I will do is I'm going to take existing presentation and then I'm going to showcase it that how we've implemented. There is a recommendation system which we implemented for Bangladesh properties. Uh, it is main goal for this project was to identify two things. One is recommend the property based on the user preference or user profile or user what they like it, right? Another one is the price prediction. If we give whatever the parameters based on the parameters or features, we can able to predict the price of the property. It can be land, it can be residential property, it can be commercial property, it can be anything, whatever the properties which are available in Bangladesh. What we did was pretty much, what you guys did, like we scrapped the data from the websites. There it was easy because there was no blocking or anything like that. It was easy. And then, we came up with a framework called Scrappy. And then, I designed initially we want to go with different one. And then, then Scrappy is easy. You don't have to do a lot of things because I made it a framework so that everybody can use it like a minimum code, and then converting into CSV or doing a lot of stuff is built in with the framework. Then once we extracted the data, then we clean the data. Then pretty much we focus a lot of time on the cleaning the data. Then we remove all the outliers, and then we identify that what are the features are mandatory, non-mandatory, and all the stuff, right? Then after removing the outliers, then we did a EDA like extensively, more than like a 10 days actually, because we want to identify that what are the dependencies, because we are doing a pricing model as well as a recommendation based on that EDA, right? EDA is the key things for modeling. Those features, assuming that prices depend on the area, zone, and other details, right? Based on that, we design the modeling, right? Uh, Today's agenda is I'll go little bit like what we did, achieve it, very high level picture. At the end, if you have any questions, I'm happy to answer, right? What we did was we built the model, right? And then we identify that what are the tasks we had to do. One is a regression task, another one is a recommendation system. We chose the content based filtering. The thing is, what is a regression model, right? Everybody knows that you want to predict something, right? We want to price prediction for the property, right? It can be any kind of a property which is available in Bangladesh. Next is recommend the property, right? If somebody likes something or based on the user profile, we can identify that what they like it, right? Those are the things. Because we didn't get a chance to, feature engineering in the data cleaning or other previous tasks. The feature engineering is very much important. If all the data is in, with small amount of the data, right? For example, if you have a data uh, from million to 2 million, right? Most of the data is at 1.2 million. And then when you do it EDA, you will know that where the problem is happening, right? Uh, for us, regression task, it is very much important for to do feature engineering. Yeah, until unless if we go with a tree model, but pretty much it is important, right? Whatever the algorithms you are going to have, if the model is not, if your data is not good, right, there is no way you can get a proper values, right? Those feature engineering, normalization and standardization, those are the standard the libraries which are available in the scikit-learn. And then based on the data, we did all the stuff, and then we identify that what are the features are critical, right? Already we know that in EDA those are the things, and then people did all the things. On the top of that, we did a grid search model, right, which gives us that which model is good, and as well as the what tuning parameters or hyper tuning parameters are very good. Those are the things. Sometimes you need to add extra columns or extra features, right? You need to customize it so that your model can understand, right? That is very important. It's all come with the EDA, right? If EDA is not good, if you don't do that one, modeling is just using API. Anybody can learn and then do the stuff, right? If the data is not good, your algorithm is so good, so super, whatever it is, right? It doesn't work. Okay. Now everybody knows, I'm just to go through. This is my slides I prepared in previous thing. This is a content-based filtering, right? Assuming that user likes something, right? Some specific, in this case, I screenshot I got from the websites, right? He likes some specific article, right? What we do is we identify that similar articles or which are available in the data set, and then we return those very closest one what is available, right? Another one is a collaborative filtering. Collaborative filtering is we identify the users which has a similar taste. Based on that, okay, if a user A likes so and so, user B likes something like different items, right? Whatever the items which are already not chosen by a recommendation system, we return those features. That's a very high level picture, but today we are going to have a little bit on the content-based filtering. This is very simple diagram, right? If A and B are the features, you can say the properties or uh, items, right? If both are similar, right? Then what we do is if A likes ABC, we recommend BCD. That's like a very high level of putting, right? Next thing is, okay, this is just a design. This is a very high level flowchart diagram we followed, right? Feature extraction, right? The user get a feedback, or you can say that now I like ABC item, right? Then okay, let's go through the process, right? And then we do whatever, if they like so and so property or so and so item, right? Then what you have to do is you need to convert into the embedding, right? You need to convert into the format, right? It is called a vectorization, numbering, right? The numbers is the only thing the machine learning understand. Those understanding, the once you convert the vectoring, whatever your input you are giving to the machine learning language, then already predefined model or a pre-trained model, you already know that, okay, this is my input, this is what is the recommendation for this input, right? We are going to give. In my system, we followed two, I mean, like we tested other vectorization, TD, TF, IDF vectorization and SBERT. It gives the good result, right? I'll go through a little bit on that. Now, if you look, right, content-based filtering and collaboration, I was going through earlier, right? The main important thing here is, right, we identify that content-based filtering. What are the items are similar to each other? That is our one aspect, right? Other aspect is based on the users. What are the user they like in the items, right, which are available in the system? That is the major important thing, right? If the item is not in the system, user, we can't predict anything, right? Those are the two critical points here, right? Now, here is the some of the models we predict, means like chose. Based on that, we best out of that, these are the pre-trained models, and then, a lot of tuning parameters and everything is available. If you look here, 768 dimensions and other things are there, right? The one, this is a Hugging Face framework. Hugging Face similarity, you can use a pre-trained model and then do it. The one good thing is, right, normally anybody is doing NLP, right? There is a lot of steps involved to get a proper data, tokenization, and all the things you had to do, right? And then when you give any deep learning algorithms, right, you need to give what is input size, right? Assuming that your input size is 64, right? You need to make it such a way that you have to give same thing, right? Now assuming that if one string is 100 100 length, right? Another one is 200 length, right? Then what you have to do is you need to padding and all the things need to be done, right? All those things you don't have to worry, right? Because these are the pre-trained model. You give an input as a string and then it will take care of everything for you. It is a very beauty. But one thing you have to do is this in order to use this model, right? Your data has to be good, right? Otherwise model can't understand, right? Now what I will do is I'll go another the one of the model I'll just show here. This is our there is so many iteration we went, and then this is we have like a so much columns and everything is there, so you can say features, right? So what I did was I identified that what are the features are critical for us, right? Now the most of the time you go and look like in the any kind of YouTube or anything, right? What they do is they pick a overview, right? Overview has a lot of information. Description is another thing. You club those two or you append those two features because those are a string, very easy to do vectorization, and then you think that everything is good, right? But that is not the case, right? Because that's where I started. I started overview, and then I was assuming that property has every detail. But based on the EDA, you can identify that what is very important, right? One is area, right? Area means like what is the amount of the square feet the property is available, right? If the area is huge, right, it costs more money. Then what is a next important thing is if it is a residential property, bedrooms, right? Then zone, right? In Bangladesh, there are what you call the way the system or the country is divided is a little different than India or other places. But they have more dependency on the zones, right? Those are the critical things. You need to prepare your text such a way that machine learning can understand, right? I will give one example. These are the features I pick it up, right? Because I need to prepare a data frame. Another important thing is one of the recommended way of doing is whenever you are doing a new data frame features, right? Don't do in place, right? Try to create another data frame. That's one of the thing. Data link and other things won't be there, right? Now the main important thing here is now all the data is available and then all the things. I need to come up with something, right? For residential, I have one string I formatted. For commercial, I prepared different string. Based on the features, which has a dependency, more dependency, I develop such a way that machine learning can understand, right? Because these are the numbers, right? You give a numbers regularly, machine learning can't identify the features, right? Because machine learning, what we are giving is we are giving a string, right? It is generating the based on the input, it is generating the features, right? It is telling that, for example, if I give a Dhaka, right? Dhaka, it understand that okay, it is a city, right? Or it can be capital, it can be anything, right? You need to tell that okay, this is the city, this is the zone, this is the thing, this is the number of bedrooms. If I give a number, right, it doesn't understand anything. You can't append the string, right? You need to come up with the okay, it has a 4-bedroom apartment, it can be, it has this many bathrooms, right? This is located in so and so zone, right? Like that we had to come up with that, and then we had to say that okay, this is my residential building, right? This is what it is, right? You need to come up with such a way that what happens is machine learning can understand. When you give a input to the algorithm there will be super duper, right? When you don't give a proper input, you never get the proper results. That is very critical. Okay, that's what I want to highlight it here is because in my use case there is a two critical things are there. One is a commercial property, one is a residential property. Commercial property doesn't have bedrooms, bathrooms, those are not mandatory because commercial is more apartment, it can be anything, right? Commercial property is more shops and other things, right? In that scenario, it doesn't make sense, right? You need to prepare your inputs a little differently, okay? Then we give the inputs to the model and then you run it and then you get a different output, and then you prepare it and all the stuff, right? You predict that, what is good, that, okay, this is returning like this, and then I'm giving a input, provide me the 1,000 square feet apartment, and then, in Gulson, like that, you can give whatever the query, right? This is a query base, and then, different things. What I will do is the next, this is a model, we prepare it. Next, what we did was we prepare a Streamlit application, then we Dockerize it, and then we deployed into AWS, right? Now, this is very simple, and then, it is not like a Dockerization and other things. I'll go in the next demo. For today, I'll focus on just what we did pictorially so that people can see. This is our homepage. We gave that, what is the, about these properties, right? Then simple search, which can enable to type something, and then it can give the input. Something like this. Then what happens is you click here, and then you can see the properties and everything. Then another thing is, these are the recommendation we call SBird, right? Then you can able to flip, right? Different properties are available, and then, it can give the similarity. These are pre-trained model. It gives a quick result. For TDI-IDF, and then, it builds only one time, and then it cache, and the next time you don't have to do. The reason I'm doing this way is, when you create a model, right, this comes to 290 MB or something. I can't push to the GitHub, and then, it is going to be complicated, because it doesn't need a lot of memory. And then the first time it takes time. Now, if I go to next time, right, it doesn't need to be there because we are caching in the Streamlit, and then it is doing all the magic, and then it gives all the thing. And then we have a recommendation, and then we have a prediction that, you give a number of bedrooms, right? And then you give, and then it is a rental property or if it is sale, right? All the things, option, whatever is there, automatically it is a base, their currency, Bangladesh rupee. And then it can be commercial, it can be apartment, it can be anything, we made it like this. And then this is one deployed in AWS, and then which is running currently. Currently it is running on the. This is running on AWS. This will be a little faster compared to my local machine. Right. Okay. Now I will stop recording, and then, if you have any questions, I'll answer it. Okay. I think, okay, before going there, and then, if somebody wants to learn a Hugging Face, I think I have a link, right? This is Hugging Face URL. Under NLP, have a sentence similarity. There is so many models are available. Okay. But as of now, I pick like a 7 models. 7 models, I pick it up, and then 7 or 9 or something like that numbers. These are the models. You can't run on the local machine. There is nothing is possible. Colab regular free version, you can't run it. You need to have a what you call paid version. Currently, I have a paid version. It costs, I believe, $9, $10, $9.99 or something like that. You can able to see, and then, it can run very quickly. But And just run it, please. Just. And then here you can set your runtime environment and everything. I set it up GPU and then maximum memory and everything. If you look here at the top, it shows Pro version. It is a $10, you can say, right? I prepare my own string, how it looks like, one of the example, so that model can understand. Okay.
Vijay, one question is this notebook available to us, or you cannot share it?
No. It is there actually. It is there in my GitHub. Everything is available.
Excellent. So that can be a very useful source for us to see in detail how you did it.
Sure. Yeah.
Amazing. And I think that we agree that the most critical part is the data preparation. So
exactly.
It was very good to see your process there. And I think that each one of us can probably download your notebook and follow your preparation process and compare it to us, because I think that the two data sets are very similar in the nature, with data with columns, with numeric columns and with text columns. So I think that we have a lot of similarities. And Amit, Vijay will share the GitHub in Slack. Yeah.
For now, these are the things you run it and then it shows the result, right? I'm just showing. Only thing I want to show here is okay, how long it took. This model, it took 40 seconds, right? If you want to run your computer, it might take more than that unless you have a lot of CPU. I tried 4 CPU, 16 GB memory on my computer. Every time it was crashing. And then free version, every time, only one time it executed, and then every time, it keep running for hours, nothing happened. Normally it used to take 3 seconds or 2 seconds like that, but this time it took only 40 seconds. But that's a good news, like that. I'm just trying to say this step, it takes a long time to prepare it, right? Once a model is there, this is very quick because you get enough memory and then done. Okay. Now I will stop sharing and then recording, and then we'll go with the questions. Okay.
I have one question. How many samples you have